Hello, unfortunately I got a phone call, so the video has stopped anyways. So here I have, as I was saying, cosine squared theta. Why am I thinking I want to change cosine squared theta to sine? Because I can see where I want to go. Okay, I want to go to something that's only has sine. So I'm thinking of taking, first of all, I personally am thinking of changing this into 1 minus sine squared theta, and I said the reason. That's what I'm thinking of, and it's a matter of trial. Maybe you will think of something else. Minus, but I'm giving you the shortest ways. Okay, do not write equals to sine cubed theta. I don't want to drag it with me and suddenly I find you taking it to the left side. Okay. Now if I distribute, I'm gonna get sine theta minus this multiplied by this is minus sine theta, and this multiplied by this, a minus times a minus will give me a positive, and 1 plus 2 will give me sine cubed theta. What happened is that this canceled this, and now we have sine cubed theta, so I have proved it. This was for question number 3. Question number 4. These are all in the Precalculus book, and I have given you the username and the passwords. You can check the Precalculus book whenever you want from the site, as I've sent you before. So again, I'm not going to work on this side. I'm thinking here plenty of things to do maybe, and I want to end up in a sine. So I'm thinking with this start to change this cotan to cosine over sine according to quotient identity. So if I go this way, cosec theta minus cosine theta times cosine theta over sine theta, what will happen? I'm gonna get cosec theta minus cosine squared theta times, I'm gonna take this up. Okay, I'm gonna take sine theta as a cosec theta, reciprocal identity. Now I have cosec to take as a common factor, for example. Again, you might have other steps, not like mine. And when you reach sine theta, give yourself a chance to try. If I take cosec theta here, 1 will be left minus cosine squared theta. And what is 1 minus cosine squared theta? Cosec theta times sine squared theta. And what is cosec theta? 1 over sine theta. If you look at the question from the beginning and you think, whoa, I don't know what to do, you will keep getting stuck. Try, work, you will reach the answer in your steps. I didn't know I'm gonna do this. So now, if I crossed one of the sine with one of the sine, I'll be left with sine theta, and here I proved it. Because sine squared theta is sine theta times sine theta, as you know. It's sine theta all squared. Question number 5. Cotan squared theta, cosec squared theta minus cotan squared theta is equal to cotan. So my answer, or what I'm trying to reach, is this, and what I'm going to work on is this. So this is full of cotans. Okay, and I have this identity that's helpful here. Cotan squared theta plus 1 is equal to cosec squared theta. I'm thinking as a first step to take a cotan squared as a common factor. Here, this will be left cosec squared theta minus 1. And cosec squared theta minus 1 is equal to cotan squared theta. I'm gonna get a cotan squared theta times cotan squared theta, and this is equal to cotan to the power 4 theta, and here I am done. Okay, this is regarding question number 5. Question number 6. The question is tan theta cosec squared theta minus tan theta equals to cotan theta. Preferably, as I said, I'm gonna work on the longer side, and I think I would go for tan theta as a common factor. I'll be left with cosec squared theta minus 1 equals to, I'm not gonna add equals to cotan theta now. Okay, you can go equals to cotan theta all the time, but don't move cotan theta to the left side. It's not, I just want to prove that the left side is equal to the right side, okay? So cosec squared theta minus 1 is equal to cotan squared theta. So now I have tan theta multiplied by cotan squared theta. So I have cotan theta multiplied, tan multiplied by cotan theta multiplied by cotan theta. And I said before, when we multiply reciprocals, they cancel each other. Why? It's something like tan theta times 1 over tan theta times cotan theta. I change this to that. This will cancel this, and you will be left with what? Cotan theta, and this is what you wanted to prove. Question number 7 says sec theta over sine theta minus sine theta over sec theta is equal to cotan theta. So I'll preferably work on the left side, and let's see how did I go and prove that the left side is equal to cotan theta. Type. There's no chance that this is wrong. They said prove the identity, verify each identity. It is an identity, and you have to prove that the left side is equal to the right side. There's no other way. Okay, if I take this sec down, then I'll have 1 over cosine theta times sine theta minus sine theta, okay, sine theta over, I'm sorry, the question actually is cosine over here. The question is cosine. Here it is cosine. So over cosine theta. So if I need to subtract these, they must have equal denominators. This has sine theta, but this one doesn't have. So I'm gonna multiply by sine theta over sine theta. What will happen now? I'm gonna get 1 over cosine theta sine theta minus sine squared theta all over. I started seeing Pythagorean identity. Cosine theta sine theta. So 1 minus sine squared theta all over cosine theta sine theta. And what is 1 minus sine squared theta? Cosine squared theta. صح? Okay, so if I change it to cosine squared theta all over cosine theta times sine theta, I can cancel the square here with one of the cosine. I'll be left with cosine theta over sine theta, and that's going to equal to cotan theta. And here, I'm sorry, the camera, I'm done proving it. Okay, so regarding question number 8, I'm gonna solve plenty and plenty of them, so you can watch as much as you can, and you'll be able to solve the homework with ease. You can solve extra questions from the algebra textbook if you wish. Actually, I wrote the question wrong. Well, okay. Question number 8 says sine theta over 1 minus cosine theta plus 1 minus cosine theta all over sine theta. That's equal to 2 cosec theta. Okay, how will I start over here? Okay, I cannot add them because I'm not gonna work on this side. I'm gonna work on this side. I cannot add them because they have different denominators. So this side needs a multiplication of sine theta over sine theta, and this side needs a multiplication of 1 minus cosine theta over 1 minus cosine theta. So here I'm gonna have sine theta times sine theta plus 1 minus cosine theta times 1 minus cosine theta. And here I'm gonna have basically sine theta times 1 minus cosine theta, and here sine theta, and this is what I made equal denominators, so I can add. If you multiply this by this, you're gonna get sine squared theta plus for here, if you distribute 1 and then minus cosine theta and minus cosine theta minus 2 cosine theta plus this multiplied by this will give you cosine squared theta all over. I'm not gonna distribute the denominator now because maybe I'm gonna cancel some trigonometric functions later. So what are you observing? Yeah, you're observing this plus this is a Pythagorean identity, the very famous one, that is 1. So now I have 1 plus 1 minus 2 cosine theta all over sine theta times 1 minus cosine theta. You have to keep your eye on the answer. The answer is 2 cosec theta. Okay, so now I have 2 minus 2 cosine theta all over. Ya Rab, yukun, you're observing, taking a greatest common factor 2 in the numerator, because that will kind of end up the question for me. If I take 2 as a common factor, I'm going to be left with 1 minus cosine theta all over sine theta times 1 minus cosine theta. And of course, this, you cancel this, I'm going to be left with 2 over sine theta, which is 2 cosec theta. And here the question has ended, because I wanted to reach a 2 cosec theta. Okay, this is regarding question number 8. I'll send you a PDF of all of that, of course. Question number 9, cosine theta over 1 plus sine theta plus sine theta over cosine theta, which is equal to sec theta. I'm going to work on the left side, and I'm going to multiply this side by cosine theta over cosine theta, and this side, you have your choice to do whatever you want as long as you will get the answer. You can make it shorter, you can make it longer. So here I will directly distribute cosine or multiply cosine squared theta plus here I have sine theta plus sine squared theta. Inshallah, you're observing what I observed. In the denominator, I am not going to distribute, trying to see if I'm going to cancel to make it shorter. Yeah, this plus this is equal to 1. So now I have in the numerator 1 plus sine theta all over cosine theta, and the question has ended. Simply I'll cancel this with this, and then I will have 1 over cosine theta, which will equal to sec theta. Proved. Regarding question number 10. Here it says sine theta over 1 minus cotan theta plus cosine theta over 1 minus tan theta. Of course, I don't like the right side. I'm gonna work on, not always, but in this question I don't want to work on this, I want to work on this. Okay, over here I tried to multiply by 1 minus tan theta and 1 minus cotan theta the way I was doing in the previous questions, but it gave me a hard time actually. So I started cancelling all of that and I tried something else. How? Okay, if I did sine theta over here, 1 minus, who will tell you? Nobody will tell you. It's a matter of trial. I cannot tell you. I cannot tell you myself. I even try. I don't know before trying. All over cosine theta. This is what I've tried and it worked to reach the answer. Here I'll need to multiply by sine theta over sine theta, and here I'll need to multiply, not this side, here I need to multiply cosine theta, cosine theta. Why am I doing that? To make the denominators equal. So here I'm gonna get sine theta over sine theta minus cosine theta all over sine theta. I subtracted in the same step. Plus cosine theta all over cosine theta minus sine theta over cosine theta, and I subtracted in the same step. Of course, sine divided by this is the same as sine multiplied by the reciprocal of those. As I told you before, you can simply take the denominator of the denominator upwards and the denominator of the denominator upwards multiplied by the numerator. In a second, you're gonna get sine squared theta over sine theta minus cosine theta. And here I'm gonna get cosine squared theta all over cosine theta minus sine theta. Okay, what is the problem over here? I wished to have the same denominator, but actually they're opposite signs. Here sine is positive, cosine is negative. Here cosine is positive, sine is negative. Remember what we used to do in this situation? I can switch places over here as long as I'll put a negative here, one negative outside. So if I did that, I'm gonna get sine squared theta all over sine theta minus cosine theta minus cosine squared theta all over sine theta minus cosine theta. Now I can subtract because the denominators are equal. صح؟ صح. So I'm gonna have sine squared theta minus cosine squared theta all over sine theta minus cosine theta. I don't have an identity for this. I have for sine squared plus cosine squared equals to 1. But I should know that this is difference of squares. How do I know? يعني by heart كده. Remember difference of squares when I used to say x squared minus y squared is equal to x minus y times x plus y, and this was difference of squares. صح? This is also difference of squares, but it's a trigonometric function. Everything we took in factoring can be included here. All algebraic, all addition, subtraction, multiplication, division, factoring, everything we used to do on algebraic terms or on numbers can be done on trigonometric functions as well. So basically this is going to be sine theta minus cosine theta times sine theta plus cosine theta, and the question has ended. Sine theta minus cosine theta, a little bit long but makes sense. This cancels this, and here's your answer. Okay, this is regarding question number 11. Okay, question number 11 is 1 over 1 minus tan squared. I've used, I think, the same method as the previous question because I found it's easier. You can give yourself a chance to try. Okay, so 1 over 1 minus sine squared theta all over cosine squared theta plus 1 over 1 minus cosine squared theta over, these are all quotient identities. Okay, so what do I need? I need to multiply here by cosine squared theta over cosine squared theta, and I need to multiply here by sine squared theta over sine squared theta to make the denominators equal. So here 1 over cosine squared theta minus sine squared theta over cosine squared theta plus 1 over sine squared theta. I'm facing opposite signs, I guess, again. All over sine squared theta. What can I do now? Take this up and take this up. So I have cosine squared theta over cosine squared theta minus sine squared theta. The questions will keep repeating themselves and the ideas will keep repeating themselves. I'll solve as much as I can and you watch as much as you can and as much as you understand. Okay, what is the problem? I wish to add them, but the denominators are not equal. So I want to switch places over here, for example. So I'm going to change this to minus. So I will end up in cosine squared theta minus, I'll do it in one step, all over cosine squared theta minus sine squared theta. So what happened? Obviously this is the same as this, so your answer is 1, and I proved what they want. This is regarding question number 11. Question number 12. 1 over cosec theta plus 1 plus 1 over cosec theta minus 1 is equal to 2 sec squared theta. So whatever you get as an answer, you must reach this. You must deal and reach this in the end. So what did I do? I multiplied here by cosec theta minus 1 over cosec theta minus 1, and here cosec theta plus 1. Sometimes I forget the second c, plus 1. So the numerator over here is cosec theta minus 1 plus, I will add directly cosec theta plus 1 all over cosec theta plus 1 times cosec theta minus 1. Okay, I'm seeing here a cancelling, and cosec theta plus cosec theta is 2 cosec theta, 2 oranges. Here it's difference of squares, so first with first, last with last, and I'm seeing a Pythagorean identity. Cosec squared theta minus 1 is cotan squared theta. So now I reached cosec 2 cosec theta over cotan squared theta. But that's not my answer, and still I can go on How can I go on? I can change this to 2 over sine theta times tan squared theta. So 2 over sine theta times sine squared theta over cosine squared theta. One of the sine theta can go with this sine theta, so I am left with 2 sine theta all over cosine theta times cosine theta. I just wrote it this way just to show you where is why did I do that? Okay, just a second. This is question number 12, right? Okay, so I just want to show you that I have 2 over cosine. Okay, I just want to show you that I have, it's 2 over cosine squared, and I have sine. So I have, yeah, okay. If I take 2, oh, so I didn't need to split that actually. I wanted to keep it as cosine squared. Okay, I'll show you why. It's the same, yani I just want to leave it as cosec squared theta, because I thought the answer wants a tan, but it doesn't want that. You must work for what you need, what is required. I want 2 over cosine squared theta, that is 2 sec squared theta times sine theta, and this is the answer. Firstly, when I did that, I thought they're gonna say the answer is 2 tan theta sec theta, but that wasn't the answer. Okay, so anyways, this is number 12. Number 13 is here. 13 cosec theta minus cotan theta times cosec theta plus cotan theta is equal to 1. Okay, I will directly distribute. These are difference of squares, so first minus last, and according to the Pythagorean identity, this one, cosec squared theta minus cotan squared theta is equal to 1, and you're done in one step. Question 14. To the power of 4 theta minus sine to the power of 4 theta is equal to cosine squared theta minus sine squared theta. Come on, I think this is a one-step job. This is the same as x to the power of 4 minus y to the power of 4, which is difference of squares. This is how I was gonna deal with it if it's x's, right? So I'm gonna do the same thing. I'll split this to cosine squared theta, and this into sine squared theta, sine squared theta. One bracket positive, one bracket negative. Cosine squared theta minus sine squared theta times cosine squared theta plus sine squared theta. This is 1, and you reached the answer. Question number 15. 1 over 1 minus sine theta plus 1 over 1 plus sine theta is equal to 2 sec squared theta. Okay, what am I going to do? I'm going to multiply this side by 1 plus sine theta over 1 plus sine theta, and this side by 1 minus sine theta over 1 minus sine theta, and let me see, where am I going? The numerator will be 1 plus sine theta plus 1 minus sine theta, and the denominator will be 1 minus sine theta times 1 plus sine theta. Okay, what happened here is that this cancels this, and I have 2. Okay, 2 over, if I distribute these, it's difference of squares, 1 minus sine squared theta. So 2 over 1 minus sine squared theta, Pythagorean identity, cosine squared theta, which is 2 sec squared theta, and you're done. Question number 16, cosine theta over 1 plus sine theta plus cosine theta over 1 minus sine theta is equal to 2 sec theta. Okay, so directly I'll multiply this here and this there. It will be 1 minus sine theta times cosine theta plus cosine theta times 1 plus sine theta all over 1 minus sine theta times 1 plus sine theta. Okay, distribute the denominator. The numerators, I'm gonna get cosine theta minus sine theta. Sorry, cosine theta plus cosine theta plus cosine theta sine theta. And in one step, the denominator is going to be 1 minus sine squared theta, which is cosine squared theta. Cosine squared theta. Because I don't have space, this will cancel this. The numerator is going to be 2 of the cosine theta, so I have 2 cosine theta over cosine squared theta is cosine theta times cosine theta. Cancel 1 with 1, you will end up in 2 sec theta. Okay, this is regarding question number 16. I will stop this video and go to, I have 2 more questions. I'll do them here and then jump to another video, okay? Question number 17 says cosec to the power 4 minus cotan to the power 4 theta is equal to 2 cotan squared theta plus 1. Again, difference of squares, I can change it to cosec squared theta minus cotan squared theta, and the other bracket is the same but positive. Okay, and I know that I want an answer full of cotan only. It has cotan only, so I am thinking of maybe changing. Okay, regarding this part, cosec squared minus cotan squared is equal to 1, right? It's equal to 1. Okay, so I can just say that this is equal to 1 and work on this part. Cosec squared theta is 1 over sine squared theta. Okay, how did I say this is equal to 1? It's cosec squared theta minus cotan squared theta is equal to 1. And here I can say 1 over sine squared theta plus cosine squared theta over sine squared theta. I have same denominators, I can add. This is 1 plus cosine squared theta all over sine squared theta. Okay, what will I do now? I'm thinking of changing cosine squared theta to sine squared theta. طيب, how I can say 1 plus cosine squared theta is 1 minus sine squared theta all over sine squared theta. If you simplify, you're gonna get 2 minus sine squared theta over sine squared theta. Okay, and that will give me, if I split this, I'm gonna have 2 over sine squared theta minus sine squared theta over sine squared theta. And this is going to be 2 cosec squared theta minus 1. But my answer is not 2 cosec squared theta, it's 2 cotan squared theta. But I can change a cosec to cotan easily using this identity again. Let me remove the cosec and write it as cotan squared theta plus 1. I change this to this because I can see the answer has a cotan minus 1. So I'm getting 2 cotan squared theta plus 2 minus 1. So I'm getting 2 cotan squared theta plus 1, and this is the answer regarding question number 18. And this is the last one from this part. Plus is you need to observe or think of them as x's. Because this is kind of gonna shock you that they do this here, but they do everything everywhere. Okay, I'm thinking of this one, as I told you, as if it's x's, as if it's x squared plus 2x minus 3. Is there a problem? When I factor this, I'm gonna factor it into x and x and plus 3 and minus 1. مظبوط. My x is cosec, not x, it's cosec. So I can write it as cosec theta and cosec theta instead of x and x. And the 3, I'm gonna write my plus 3 because the bigger one in the middle is positive, and minus 1. Any problem? No problem. The denominator is difference of squares. I can write it as cosec theta minus 1, cosec theta plus 1. And here I go, I'm gonna cancel this with this, and then I'm gonna get my answer over here. I will open another video. See you!